Hello dear students, in today's video we will learn about interference of light. For understanding interference of light, we should know first what is superposition principle, what is meant by coherent sources of light, and what are the meanings of destructive and constructive interference. So first we will learn what is meant by superposition principle. When there are more than one wave is traveling in the same direction or in the opposite direction, when it falls on one over the other, it falls on one over the other, the displacement produced by each wave will be added to one another. So what happens is the resultant wave will be, the displacement of the resultant wave will be the sum of the displacement wave of the waves produced by each of the waves. We can show like this: if y1, y2, y3, etc. are the displacements produced by each of the wave, if n waves are there, we will add all of them and the final result, the resultant waves displacement will be y. So y1, y2, y3, etc. are added algebraically so that the displacement will be y. For example, if a wave is there like y1, if we are adding two waves, for example, y1 is a wave with a displacement y1 is equal to a cos omega t, and y2 is another wave with a cos omega t plus phi. If these two waves are added up, we will get a resultant wave called y, which is equal to y1 plus y2, and for that we have to add this equation 1 and 2. So first wave has a 0 initial phase, and the second wave has the initial phase phi over here. Now when we add these two together, what will we get is, we will use the identity that is cos A plus cos B. Cos A plus cos B is cos A plus cos B is equal to 2 cos A plus B by 2 into cos A minus B by 2. When we do this in the two equations like a cos omega t and a cos omega t plus phi, y will be resulting as 2a cos phi by 2 cos omega t plus phi by 2. So this part of the wave, that is 2a cos phi by 2, is taken as its new amplitude. So y is equal to, we can say, a dash into cos omega t plus phi by 2, where a dash is the new amplitude of the wave and y is the new resultant displacement of the wave. Now we will understand what is meant by constructive and destructive addition of waves, or constructive and destructive interference of waves. Now you see here in this first figure, there are two waves like wave 1 and wave 2, they are named as, and they are overlapping with each other. So you can see here the crest is overlapping with the crest and the trough is overlapping with the trough. They have the same, exactly the same amplitude, same time period, frequency, everything. They are identical in all aspects. So when they superimpose, according to the interference superposition principle, that y1 is added to y2. That means x is added to x and you get a 2x displaced curve, crest, and here minus x is added to minus x, that is a minus 2x displaced trough you get. So that is the resultant wave. At the same time over here, what is happening is wave 1 and wave 2 is there, but wave 1's crest is overlapping with the wave 2's trough. Because they are exactly of the same displacement in the opposite order, x positive and x negative, you see the resultant here, it is equal to 0. Even here also minus x is added to plus x, resultant is 0. So what is destructive interference is when two identical waves are superimposed exactly out of phase, meaning 180-degree difference, they are overlapped. Then what is happening is called the destructive interference. So if in case if x and minus 2x was added up here, for example, if this was minus 2x instead of minus x, there will be a residual minus x trough over here, as well as here also there will be a plus x trough will remain. So that also can happen. Here it is exactly the same displacement, so that is why when they were added the resultant was equal to 0. This is meant by coherent sources. When two light bulbs of identical power or brightness, everything is there, and if we try to superimpose their light, what will happen usually is you will get a more brighter light, but there won't form any interference as such there. So what causes the interference of light is the superimposition of light from two coherent sources. What is meant by coherent sources? That is two sources which are having the exactly the same frequency and the same phase or constant phase difference. They are called coherent sources. So coherent sources, getting coherent sources from a group of identical sources is not an easy job. So what will we do is, where is this coherency is lost in sources is, they may not possess the same phase or constant phase difference. The phase of a source of light is decided by their atomic vibrations. So it is not identical for uh, every like sources. So getting a coherent source is a very rare chance. And if you select thousands of identical sources, getting a coherent source is very minimum. So these two conditions are very much required, that this frequency should be exactly the same as well as the phase should be the same, so that the coherency of sources is obeyed. And only coherent sources can produce interference. Now here in this figure we have a main source SO, then there are two slits in front of it which is working as the coherent sources S1 and S2. So the beams of light which are coming from S1 and S2 will work as coherent sources. When they overlap, there will be crest overlapping as well as trough overlapping in some places, and in some places there will be the crest overlapping with the trough. And you can see here the red dots over here is overlapping the crest to crest or the trough to trough. So that will produce a maximum intensity. Similarly, if a crest is overlapped with the trough, as in this case, what is happening is a minimum intensity you get. So this is of a maximum brightness, this will be of minimum brightness. In real picture, if you see this, that will look like this. This is a bright fringe, this is a dark fringe. So what is bright fringe? The meaning of bright fringe is either the crest is overlapped with the crest or the trough is overlapped with the trough. Here in the dark region, it is the crest overlapping with the trough. So that means this is the white patch. What we are saying is a constructive interference. This one is a constructive interference, and this is the destructive interference. Now we will see the conditions of the constructive interference and destructive interference mathematically. So earlier when we discussed the overlapping of two waves mathematically, we got y as equal to a dash cos omega t plus phi by 2. So what was this a dash? Was actually cos phi by 2. it was 2 cos phi by 2, isn't it? So this 2a cos phi by 2 was a dash earlier. So that we can make use in the calculation of intensity. I is proportional to a square, that is the square of the amplitude. Now the amplitude is a dash, so it will be a dash square. So I is equal to, we can say it is 4a square cos square phi by 2. So initially the amplitude was A. So if you consider I0 as the initial intensity, so I0 is proportional to A square. So we can say I is equal to 4I0 cos square phi by 2 is the new intensity of the wave. Now if we give certain angle values here for phi, then we can find out that the intensity is sometimes maximum and in some other angle conditions it is minimum. So we will first find out what is constructive interference conditions can be. For constructive interference, this value of phi, if you give for example 0 or 2 pi or 4 pi, etc. That is even multiples of pi if we give, we can say I is equal to 4I0 cos square phi by 2, that is cos square 0. Cos square 0 is 1. So it will be 4I0. Similarly, when you give 2 pi here, 2 pi by 2, that means it will be pi. Again, cos square pi is 1 only. So that will be again giving you I is equal to 4I0. So when we give 5 values as 0, 2 pi, 4 pi, etc., I will be at its maximum, that is 4I0. That is the condition of constructive interference. Now destructive interference conditions we can check. For destructive interference conditions, 5 values has to be given as say plus or minus pi. Here also that is plus or minus only. Plus or minus pi, plus or minus 3 pi, plus or minus 5 pi, etc. That means odd multiples of pi. Here it is even multiples of pi. Here it will be odd multiples of pi if you give. You can see that I is equal to 4I0 cos square pi by 2. Pi by 2 is 90. So cos square 90 is 0 value. So I will be equal to 0. If you give 3 pi, it is 3 pi by 2. So 3 pi by 2's value 270. That also the cos value is 0. So that means for all these angles, I will become 0, which is the minimum value of intensity. So in terms of angle, if you say phase difference, if you say the constructive interference is caused when there is an angular difference of 2 pi each, that is in even multiple of pi's, and here also 2 pi each only, difference is 2 pi each, but the angle conditions are odd multiples of pi. Conditions of constructive and destructive interference we can express in terms of path difference also. This is phi is the phase difference. Similarly, we can make it in terms of path difference as well. So when we take a sine wave, uh, this is how the sine wave looks like. So this is called its lambda, which corresponds to a 2 pi angle. So here the path difference, in terms of path difference, if you say the constructive and destructive interference. For constructive interference, we can take the path difference is delta is equal to, how much we will say, like 0, 2 pi, 4 pi, etc. That means it will be 0, 2 pi corresponds to 1 lambda. So lambda 4 pi corresponds to 2 into 2 pi, that means 2 lambda, etc. Similarly, destructive interference, if you check, uh, plus or minus pi. Pi meaning in this wave this much only, pi. So this is how much it is, lambda by 2. So we will say delta minimum, delta for minimum intensity is lambda by 2, then 3 lambda by 2. 3 pi means if pi is lambda by 2, then 3 pi should be 3 lambda by 2, 5 lambda by 2, etc. So this is n lambdas. Okay, n lambdas. Delta is equal to n lambda, where n equal to 0, 1, 2, etc. Here it is delta is equal to half lambda, then 3 by 2 lambda, 5 by 2 lambda, etc. So odd multiples of lambda it is. So that we can say it is 2n plus 1 lambda by 2. Again n is 0, 1, 2, etc. So delta minimum happens, meaning destructive interference happens at 2n plus 1 lambda by 2s, and maximum intensity we get at delta path difference is equal to n lambdas. Or if you want to write it this also as lambda by 2, what you can say is it is 2n lambda by 2s. 2n lambda by 2. So both can be in terms of even multiple of lambda by 2. Here it is odd multiple of lambda by 2. Next we will study the most important topic of the lesson, Young's double slit experiment. The aim of the experiment is to find the fringe width or the bandwidth of the interference fringes. Bandwidth or fringe width is called as beta. What is beta is? It is the distance between two consecutive bright fringes or two consecutive dark fringes. So for the experimental setup, it consists of a monochromatic source of light. Here is the source of light. From that there is parallel beams of light are coming. So source of light will be somewhere here. Then the parallel lights from that. There is a slit, main slit over here. And in front of the main slit there are two small, very small pinpoint like slits S1 and S2, which are located very close to each other. D is in millimeter range only. Now there is a screen here. This is the screen. So the screen is comparatively at a larger distance. This is the screen. It is at a distance D. D is comparatively a larger distance. So you can see that waves from S1 and waves from S2 are overlapping with each other at P, and P may be a bright point or a dark point according to what type of wave structure is overlapping over there. If two crusts are overlapping, it will be of maximum intensity or constructive interference happens and it will be a bright fringe, or trough is overlapping also, it will be a maximum intensity point. But if a crust and trough overlaps, as we discussed earlier, it will be a dark point. So this is the figure representing the Young's double slit experimental setup. Now the sustained interference pattern, if we have to get on the screen, there are certain conditions are there. For that, first condition is both the sources S1 and S2 must be coherent. Then the distance D should be very minimum, and the distance capital D, that is the distance between the sources and the screen, source and the screen, must be comparatively larger. Now you see O is the, so these are the three conditions for sustained interference pattern. S1 and S2 must be coherent. D should be minimum distance. D should be at a larger distance compared to small d. Now O is the center of the slit, center of the screen, and P is a distance y. P is a point at a distance yn. Now we will find an expression for bandwidth beta. So next we'll write here expression for bandwidth. So here there are two sources, S1 and S2. You can see that S1P and S2P are the distances to the point P, whether the point be a dark point or a bright point. There is a difference in their path. How much these paths are different, that is S2P is a longer path than S1P. So if you draw a perpendicular from S1P to S2P, you get this extra distance in that, which is called delta, the path difference called delta. So if this angle is theta, from the triangle S1, S2N, we can find sine theta. Sine theta is equal to S2N divided by S1, S2, which is D. So S2N is equal to D sine theta. That is what we have written here as D sine theta. This is called the delta value. The path difference delta is called S2N, which is equal to D sine theta. Now we have to find out beta. Beta is the distance between two consecutive bright fringes or dark fringes. So we'll find out the expression for beta. For that we should first go to this one, this triangles here. That is, we will connect here. This one is a triangle as well as this is a triangle. So we can call this as R and Q. So S1QP is a triangle. So in S1QP triangle, we will find out what is S1P square. So S1P square is equal to S1Q square plus QP square according to Pythagoras. So QP, what is QP here? So this is D by 2. This distance OQ is called D by 2. Similarly, OR is also called D by 2. So S1Q square is nothing but S1Q is this distance. So that is actually D. So this is D square plus QP. QP is this distance only. So that is Yn minus D by 2 the whole square. Yn minus D by 2 the whole square. So this we will take as equation number. This is our equation number 1. This is equation number 2. Similarly, in triangle S2RQ, sorry, S2RP, 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 we will take S2P square is equal to S2R square plus RP square. Again, S2R is this distance which is D. So capital D square plus RP is from here to here. So it is Yn plus D by 2 the whole square. Yn plus D by 2 the whole square. Now, we'll write S2P square minus S1P square is like A square minus B square, which is S2P minus S1P into S2P plus S1P. In that, S2P minus S1P is called delta. So we'll find out what is S2P minus S1P. So this is our equation number 3. This is 4. Now, S2P square minus S1P square, we will find out what it is. So we have S2P square minus S1P square, which is equation 3 minus 2. So when you do that, we get the difference as 2YND we will get. because there is d square which is getting cancelled, and u minus, as well as a minus b the whole square and a plus b the whole square. So a plus b whole square minus a minus b the whole square we have to do, which is 4ab. So 4 into yn into d by 2. So that is nothing but 2yn into d. So we got s2p square minus s1p square as 2yn into d. This is our equation number 4. So 2yn into d is equal to delta into s2p plus s1p. s2p plus s1p, we can take s2p and s1p are very close to each other, almost parallel. So we can take it as 2d. 2 times capital D. So we'll write that as 2 times capital D. So yn is equal to 2d delta divided by 2y2, 2d. So 2 get cancels, and this is d delta divided by d. This is our equation number 5, yn value. Now, if P is a bright point, P is a bright point, we have learned already the condition of delta. So delta should be n lambda. That is the condition. So what will be yn? Yn is equal to d n lambda divided by small d. Now we will take beta. Beta is like yn minus yn minus 1 or yn plus 1 minus yn, like that. Two very close values, consecutive values. When you minus, you get beta. So what will we do is we'll take y1 and y2 to find beta. So y1 means n has to be given 1. So that is d lambda by d. And y2 is n has to be given 2. So 2d lambda by d. Now beta is y2 minus y1, which is 2 minus 1. D lambda by d is common factor in both. So it will be just d lambda by d. So beta we got d lambda by d. So this is when it is a bright point. Now when the if P is a dark point, if P is a dark fringe, at P we get a dark fringe. In that case, what will we do? We will substitute delta's condition of darkness, that is 2n plus 1 lambda by 2. So what we get? Yn is equal to d 2n plus 1 lambda by 2d. So y1, y2 will write. y1 is when n equal to 1. So that is d into 2 into 1 plus 1, that is 3 lambda. 3d lambda by 2d. And y2 is when we give 2 for n. That is 2 2s are 4 plus 1 5. So it is 5d lambda by 2d. So when you find beta, again y2 minus y1, that is 5 by 2 minus 3 by 2 into d lambda by d, which is 2 by 2, nothing but d lambda by d itself. So this is B for dark fringe and this is for the bright fringe. Both are the same. So what is our conclusion is, whether dark fringe or bright fringe, the beta value remains the same. Beta dark is equal to beta bright. So that is our conclusion, which is nothing but d lambda divided by small d. Intensity of interference fringes with path difference is plotted in this graph. This graph shows that the intensity I maximum is the same for all the wavelengths. That means whether it is a dark point, the darkness intensity is the same, as well as for the brightness, it stands on the high level, at the sustained level only. So whether it is dark or bright, the intensities of the bright fringes remains identical, as well as the dark fringe intensity remains identical in this.